Hello friends, in this video we were going to look at how we can simulate CMOS inverter circuit using Cadence Virtuoso suite. So first we have to select the path. For that double click on student's home and you can observe here a folder by name database is there. So double click on that database. So you can observe two folders are available here. One is analog folder and the other one is digital. When you are doing any analog designs, you can double click on that analog folder, and when you are doing a digital design, you have to double click on digital folder. Since we are doing analog design, I am going to click on analog folder. Okay. Now here we have to create a folder or we have to select the path. For that, right click, select open in terminal. A command prompt window is opened. You can see this command prompt window over here. So this command prompt window will here what are the various commands we have to execute and the files we have to execute, we are able to see in this open terminal window. See, first we have to initialize C shell scripting. See, when you are working with EDA tools or a Cadence tool, always you need Linux platform or Linux operating system. So when it comes to Linux operating system, this Linux operating system has got two basic scripting. One is bash scripting and the other one is C shell scripting. Always Cadence EDA tool will be working with C shell scripting only. So we need to initialize C shell scripting. So to initialize C shell scripting, we have to use the command called CSH. See, here I am typing the command called CSH. You can just look at it here. I am typing the command called CSH. So once if you type the CSH command, you need to source CHS file. So in which CSHRC file will be called as C shell scripting run command file, in which the tool data will be available, where there is the path of the tool and where is the location of the tool, everything will be available. For that you have to source this CSHRC file. For that I am typing the command as source space CSHRC. Press enter. To initialize C shell scripting, we have to use the command called CSH. See, look at it here. I am typing CSH. And we need to source this CSHRC file. So in which CSHRC file will be called as C shell scripting run command file, in which the tool data will be available or the path of the tool and where the location of the tool is available. All these things will be available. So I am going to type source space CSHRC. Press enter. See, now you can see that. So all the information will be getting from CSHRC file. So once after sourcing CSHRC file, so you can now see in the confirmation window here. You can see, look at it here, the confirmation window message will be there that welcomes you to the Cadence tool suite. If you are not able to see this message, which means that the path may be not given proper or incorrect path may be there, where you have to go again and we have to check where the path of that tool is located, everything we have to check it. Otherwise you can go ahead with the tool. So here where is the path is located, for that you can type PWD. You press enter. See here, now the path is home, students, database and analog. Just now we have done it, all these things. So the path of where we can, the tool is located is home, student, database and analog. So to invoke the tool, we have to give the command as Virtuoso space ampersand. So this is, if you press enter, you can see a command interface window will get open here. See, now you can look at it. This is, we call it as command interface window or CIW window. It takes some time to invoke the tool. Kindly you have to wait for a while. Okay. So this is, we call it as command interface window. So right now we can start creating the schematic symbol and we can perform the simulation. Okay. So first and the foremost thing is, you go for file, select file and you select new and you select library. So here you have to first create a library. So here for example, I am going to create the library by using the name called tutorial. Okay, I have created the library by name tutorial, and after naming your library, you have to attach this library to the technology library. So press here, so attach to an existing technology library. So now you press OK. So there are various libraries will be available like GPDK 90, GPDK 180, in which technology library we are working, that we have to select it. Right now I am working in GPDK 180 technology. So click on GPDK 180. What is this GPDK? General Process Designer Kit. After selecting this GPDK 180, you press OK. So now you can see here your library has been created. You can just go for open and check here. You can check your tutorial is there. So your library has been created. So once the library is created, you can start working the various design under this library. So now one by one we can start working on that. First, what is the design we are doing today? We are doing inverter design, correct? CMOS inverter design. So for that you go for file, select again new, and here you select cell view. So you can observe a new pop-up window has been opened here. Now you select your library. By default other libraries will be there. Also you have to create, you are going to design the CMOS inverter in your library. So for that I have to choose my library. I have chosen tutorial. Now you can give any name, cell name. So since I am doing inverter, I am just giving it as an inverter itself. Okay. So type, you can just look at it. It is schematic. Open with schematic L is there. You press OK. So now you can look at it here. Editor window, schematic, Virtuoso schematic editor window has been opened here. Okay. See, look at it here. What is your library name? It is tutorial. What is the cell name? It is inverter. So tutorial inverter schematic. So here we have to first capture our schematic. As you know that the CMOS inverter consists of two components like PMOS and NMOS. Where it is available, how we can place it in this editor window, all these things we are going to learn now. So for that you go for create option here. You take instance, browse. So all these instances will be available. All these components will be available in GPDK library. You can just look at this window, library by browser window, where we can add the instances. So now you select GPDK 180. Okay, what I want in order to, what I require in order to draw the schematic of a CMOS inverter, I require one PMOS and one NMOS. So you can just click on that PMOS and you can click on this symbol, it is already highlighted. You close this, and if any if you want to change any specifications and all that, you can modify it here. You can change it. By default, I am using total width is 2 micrometer and length is 180 nanometer technology only. I am doing the design. So you hide it, place it in the editor window and press escape. Similarly, I want one NMOS. So go for that. Again, create instance. You can browse it and you can select GPDK 180 and you can get the instance from there only, or because since NMOS is available in the GPDK 180 library only, already it is available, here only I am going to change it. Just NMOS, click NMOS. Okay, same specification I am going to use it here. If you want to change any specifications, you can modify it here and press hide and place it on the editor window. As you know that we require one VDD pin, VSS pin, input and output. How to create the pin? So for that, here, see here, you can go for again create pin. Here it is available. At the same time, if you just look at the toolbar here one pin symbol is there, no? Create pin. You can shortcut. You can use this only. Go for create pin. What I want input pin. So I have to give the name for the input pin. I will give it as X. And I have to give the direction also. What is the direction? It is an input pin. So set the direction as input, hide it and place it. Okay. Press escape. Again, which pin I want? I want Y. So again go for create option, pin option and give the name. I will give it as Y. And here you should change the direction. So Y is output, correct? So click on output. See here there are, if you pop down this arrow, you can see the direction of the pins, input, output, in, out, switch, jumper, everything. But we are using input, output, sometimes input, output pin. Right now Y output pin, Y is output. So I am going to select direction as output, hide it and place it here. Press escape in order to come out of the window. Okay. So I want VDD. So go for again pin option. You type VDD. But here VDD and VSS both are input pins only. So change the direction as input, hide it. So if you want to rotate these pins and all, you can press in the keyboard. You can press R. See, you can see the rotation of the pin. For rotation, you can use shortcut method. So in the keyboard, you can press R. Okay. What I want next? I want VSS. Again, the direction is input, hide. You rotate it and place it here. So now I got all the pins I have taken and I have got NMOS, PMOS which is required for this CMOS inverter design. Now I have to connect it all these things through wires. See here, if you just look at the menu bar here create wire narrow, create wide wire, everything is there. Or you can use a shortcut key called W also in the keyboard. So just click on this VDD, connect it to source. This drain and this drain I am going to connect it. Again this source to VSS. Gate and gate should be shorted. Okay. Connect this input pin and here connect the drain and drain of PMOS and NMOS to the output, and remaining substrate I have to do the connections. Do the connections of the substrates. Okay. See, all the connections is over now. You press escape. Now I want to check whether any errors are there. Errors in the sense it can be an open circuit, or if you have not connected any wire, wire to any of the instances or the pins, that you have to check it out. For that you can see there are two options here. Here one save option is there, here check and save. Usually if you save, the errors will not be highlighted, it will save your design. But we have to go for check and save, means you should check it and it should give the results, what any errors is there or not. So check and save, where the error will be highlighted. So again come back to this CIW window. See, you can find out here Virtuoso. You click on that. See, now you can see schematic check is completed with no errors. Okay, so this is my tutorial, is my library name, inverter is my cell name, and this is the schematic whatever I have done it. Okay, this is one part. So now the schematic capture is over. Now the next step is we have to create the symbol for this inverter. For creating a symbol, what you have to do is here, go for create option here. Okay, select cell view, and from cell view. So you can see here your library name, your cell name, schematic, and what you are doing your symbol. You press OK. See, here only you can adjust whichever pin, which side you want. Suppose I want VDD at the top, VSS at the bottom, X pin left, Y pin right. Here only I can do the adjustment. See here, Y pin is already at the right side. So I will keep it as it is. I want VDD at the top. Just cut it and paste it here. So I want VSS at the bottom. Control X, Control V. Similarly, I want X pin left on the left side. Okay, here only you can do the modification. So you press OK. And now we can see the symbol, but the green color which is highlighted will be the symbol. It is a border. I'm going to delete all these things. I don't require these things. Okay, I don't want instance name also. Okay, this is your symbol. Okay, symbol just it is a representation of your schematic. Either you can keep it like this, or you can do the inverter symbol. That is left to you people. Okay, suppose how to create the normal schematic symbol of a inverter circuit. For that I am going to delete all these. Only I'm deleting the extra things. I'm keeping only the pins over here. Okay, for that you can just look at it here in the menu bar. Circle, ellipse, line, say arc, everything is there, no? So I'll go for create line. Okay, and I want circle. Take that, create circle, just place it and click it. That's it. Okay, then I have to move all these pins here. So how you are going to move this? See here, move option is there. Select this, select this line, go for move and move all the pins. Similarly, you can move this VSS also. Now you can see the symbol of an inverter. Okay, after creating the symbol, again you go for check and save. After that, again you can check it whether your schematic and symbol is matching with each other. Go for Virtuoso window, you can see, you can just look at it here. Cross view check completed with no errors. Cross view check completed with no errors means it is cross verified with the schematic and there is no errors left here. Okay, so you can minimize this. Now you can close this symbol window as well as schematic. Okay, now what you have to do now is you have to create now the test circuit. Now we have to test for the functionality of the design, whether my inverter is performing or working according to the design. Okay, so for that, go for File, New, select Cell View. So you have to give different name for the test circuit. So your library will remain the same, only the cell view will be changing. So I will give inverter test. Okay, you press OK now. So you can just look at your library is tutorial and your cell name is now inverter test. So test circuit you should give different name. Okay, now I want to check the functionality of the design. So for that I will go for create, instance, browse, and here I have to select my library. I have to select tutorial. Here you can just observe inverter and inverter test. Inverter test is the test circuit where we can check the functionality of the design, and inverter is nothing but we are having a circuit symbol, or we have just now created. So symbol is available in my design. So close it, hide and place it in the window. Okay, now I should give the inputs, the biasing, everything. So input here is we are going to give a pulse, V pulse. So for that go for create option, instance, browse. So all these sources will be available in analog library. So if you just go for this library, select analog library, and here cell you can select V pulse here. Just give that pulse and symbol is available, close it. See here we have to give the specifications here. What is the voltage 1, what is voltage 2, what is rise time, what is fall time, what is the period, what is the width of your pulse, everything we have to specify because the tool doesn't know, correct? So here I'm going to give voltage 1 as 0, voltage 2 as 1.8, or you can give it 2.5 or 5 volts. That depends on your design. Period I will take by default 20 nano. Don't give seconds, just type 20 nano, automatically the seconds will be taken out. Rise time I will give it as 1 nano. Fall time I will give it as 1 nano. Pulse width I am going to give it as 10 nano. You can change it depending upon your design, you can change the specifications. Okay, by default I am taking these values. Hide it, place it here. And look at it, one more thing. See, this is the yellow color line you can observe is right. That is your boundary of your symbol. If you place it, these components inside this boundary, suppose you can't place this inputs and all like this, because see here it will be overlapped. You place little bit far away from that. Otherwise you will get the error. Okay. Next I have to give the biasing voltage. So for that I have to go for create, instance, browse, and the biasing voltage is also available in the same library. VDC is there, no? Symbol, close it, and here you can give any voltage 1.8. Okay, don't give volts, just you give the numerical values, automatically it will take, right? Otherwise you will get error. When you are going to perform simulation, you are going to get error. Hide it. So you can press R and you can place it here. I am connecting to this VDC. Okay, now I require ground pin. So for again create, instance, and the ground pin is available in the same library, analog library only. Here only you can change it. G and D you press. Hide it. Wherever I require ground pin, just place, go on placing. I require ground pin here and ground pin one here, one more here. Okay, now connect all these things through wire. See here, you can use the wire here itself. So input, I am going to connect it. See here, you can observe it, output pin is floating here, where I can select, where I can get the outputs. So it is floating here. For that I am going to use a pin, output pin, one more output pin. You can give different name there, and direction you change it, output, hide it, place it. Now you can connect this one also through wire. Okay, all my connections are over now. Now check and save. Any errors is there? Again we have to go for CIW window and find it. See, schematic check completed with no errors. Extracting inverter test circuit completed with no errors. Okay, minimize it. So now we have to do the simulation. For the simulation we are going to use tool called Spectre. For that, go for launch ADEL, and here we can do transient analysis, DC analysis, AC analysis for amplifier circuits and all. We have to select what type of analysis we are going to do it. For that, go for analysis, choose. See here, look at it, different analysis will be available. First we'll do transient analysis, and here you have to give the stop time, and I am going it as 100 nano. Okay, and in order to enable this window, you click on moderate, you press OK. Next, come for outputs to be plotted, select on design. Means what are the outputs I have to observe. So all these things I have to select it on the design. See, I want input and output. So select on wires here, input wire and output wire, that's it. So again come back to this window, go for run option. So you can observe it, split here. Now we can observe the results of the transient analysis. Okay, it is input versus output, correct? So if you have given, this is your input and this is your output. If you give 1, the output is 0. That is you can verify the functionality of your design. So if you want to change the colors, you can click on this, right click, go for color option and click yellow color. Or if you want to view another, go for color and you can select blue option. Okay, so this is the transient analysis. Okay, input and output voltage with respect to time. So now we'll do DC analysis. For that, again come back to this ADEL window. Now go for again analysis, choose. Now I am going to choose DC analysis. I have to save the DC operating point. That's why I am going to click on that DC operating point. And here I have to select the component. So click on this component parameter, select component, and here you have to select the input. Okay, click on that and you make it as, select the DC voltage, you press OK. Again come back to the same window. Here you have to give start and stop time. Start is 0, stop time is 1.8. Since we have given the biasing as 1.8, I have given it as what? Stop time as 1.8. Suppose if you have taken the biasing as 2.5, 5 volts, you can give the start time as 0 and stop time as 1.8 volts. Again, okay, sorry, it is not time, it is sweep range, it is a voltage. Since you are taking the voltage as 1.8 volts DC voltage, start time I have given as 0 and the stop time stop voltage I have given it as what, 1.8 volts. Okay, it is a sweep range. Okay, you press OK. Again you come for this outputs to be plotted, select on design, already it is highlighted, no need of selecting once again. Go for run option. Okay, now we can observe the DC analysis, output versus input. Okay, so this is your operating DC operating point, that is the Q point. You can just observe it. You can change the color and you can observe it. This is the operating point. Okay, thank you.